Hello and welcome students. Welcome to Engineers Arena. So this is the lecture number 2 for our Bpsc AE test series. Test number 1.1, question number 2A. So this question is also from surveying. Let us begin directly from the question. The following readings were noted in a closed traverse. Fore bearing and the back bearing of the lines are given as follows. At which station do you suspect local attraction? First you have to calculate at which station do we have local attraction. Find the correct bearing of the lines. You have to find the correct bearing of the lines. Okay. What will be the true fore bearings? As this is actually fore bearing. What will be the true fore bearing as reduced bearing? We have to write true bearing as reduced bearing. Okay. If the magnetic declination is 12 degree west. So at first we must know from at which station there are local attraction. Then we will change we will calculate the correct bearing of the lines where the station on which we suspect the local attraction, and then we will be calculating true bearing as reduced bearing of the lines if the magnetic declination is 12 degree west. Okay, so let us begin. Let me make one table first of these lines. Okay, the line which we are having is AB, BC, CD, DE and EA. Okay, this is the line. Fore bearing of the line is given as fore bearing and back bearing is given to you. I will directly copy it. Fore bearing is 32 degree, 77, 112, 122, 265, and back bearing is 212, 262, 287, 302 and 85 degree. Okay. Now if we want to calculate where is the error, so what we do for calculating fore bearing and for where there is the difference from where there is, if we are going from 180 degree, if we are calculating the error, what we have to do, we have to check the difference between the fore bearing and the back bearing. If it is 180 degree, then there is no local attraction. If it is not like that, then there is local attraction. So at first, if the angle is if the back bearing is given as, like, if back bearing is given as 220 is greater than 180 degree, then what we'll do? We'll do 212 minus 180 degree. That will be equal to 32. That is station A, B, line AB is free from local attraction. Line AB is free from local attraction. Okay. Let us calculate the error. We are calculating error. Here error is 0. There is no error. Now if it is 262 minus 180 degree, what will get? 262 minus 180 is 62 plus 20, that is 82 degree. And what is fore bearing is 77 degree. Therefore what will the error? 82 minus 77, it is equal to 5 degree. So this is 5. Okay. Now again 287 minus, from here 287 minus 180 degree, what will be this? Is equal to 287 minus 180 will be 87. So in 107 degree. Again there is error. How much? 112. This 112 minus 107, that is equal to 5. So here there is also error. Now again 302 minus 180 degree. 302 minus 180 degree, what it is? It will be, that is 122 degree. So here there is no error. And here it is 85. So we will be, it lies in this region, 85. What we will do? We'll add this 85 plus 180 degree. Previously what we did? We did subtraction. Why? Because back bearing of the line was greater than 180 degree, so we subtracted it from 180 degree to calculate our to calculate the error. calculate the fore bearing basically, and from there we checked that from this column, and we identified the error. Over here, what is this? The case changes. The back bearing of the line is less than 180 degree, that is 85 degree. What we will do? We will add 180 degree to it. What will this? This will be equal to 265 degree. So 265 degree. Here also 265 degree. So there is no error. Here we have calculated the error. Now we want to calculate corrected fore bearing and corrected back bearing. We want to calculate corrected fore bearing because here we found the error. So if we want to calculate corrected fore bearing and the corrected back bearing, what will it be? Corrected back bearing. I must delete this you can show in rough or you can calculate. I will be deleting this. What will the corrected fore bearing and corrected back bearing? First we have to calculate. So you see that line BC and line CD has error of 5 degree. That means C is common. C is common in both. That is station C. That is station C is affected from local attraction. From here we can infer that station C is affected from local attraction. From local attraction, I am writing local attraction as LA. Okay. So based on this, now we must calculate what is the corrected fore bearing. That is the correct fore bearing of line AB. That is fore bearing of the line AB will remain same as and back bearing will be also remain same because station A and B is free from local attraction. So station A and B, so this will be but 32 and this will be 212. No problem in this. And over here, what we found? That station C has local attraction. So from here you have to be careful. Okay. Since station C has local attraction, therefore station C has local. As we move from B to C, the fore bearing of the line will remain same. The fore bearing of the line remains same. That is, it will be equal to 77 degree. But the back bearing will change. That is, it was 262, and the error is 5 degree. That is 262 minus 5. That is equal to 257. Now you calculate 257 minus 257 minus 77. What will it be? 180 degree. Therefore, we are going right. Okay, if we subtract this 2, we should get 180 degree. So 257 minus 77 is 180 degree. Therefore, this is the correct bearing, correct fore bearing and the correct back bearing. Okay. Now again station C. Now this time this had error, and now at this time which error would be at station C? The fore bearing, that is the station at which we are founding. The local attraction. What is happening in that? The back bearing of the line BC. That is, if you are moving from B to C, suppose this is B and this is C to D. And just for explaining, the line of survey is this. Then at this point BC, here it will be back bearing. For line BC, this will be back bearing. If you're drawing like this would be back bearing. Okay, so this will be having error, and fore bearing of line CD. See, this is point D. This is not D. This point is D. And the fore bearing, that is back bearing of the line BC, and the fore bearing of the line CD will have error if there is local attraction at station C. So which will have error? This station, this will have error. That is, how much it is? Error is 112 degree. Therefore, correction will be 112 minus 5. That is 107 degree. Now, simply add 180 degree to it. You will get 287 degree. It was 287 degree. Now we can see the difference. That it is 180 degree. Therefore, it is correct. Now, other station did not had any local attraction. So there will be no error in the other. So I am directly copying this 302, 265, 85 degree. Now you have been asked to calculate the reduced fore bearing. Okay, I'm deleting this. This was just for explanation. Now, if you want to calculate the reduced fore bearing, because in the question, at which station do you suspect local traction? That is at station C. C is the answer over here. Find the correct bearing of the lines. This is the corrected bearing of the lines. Okay, these are the corrected bearing of lines. So if we have completed up to this, now it asks what will be the true fore bearing as reduced bearing. Okay, we have to calculate fore bearing as reduced bearing. Okay, you have to calculate only fore bearing. Okay, fore bearing, that is this one fore bearing. Reduce fore bearing of the lines if the magnetic declination was 12 degree west. Okay, reduce fore bearing. First we must calculate reduce fore bearing from this column. What will be this? From whole circle bearing, if we move from reduced bearing, how we do it? Let me explain it short. For example, I am taking from this only. If it is 32 degree, the whole circle bearing is 32 degree. What is reduced bearing? This direction is north, this is east, then that is north of 32 degree east. This is the reduced bearing. If it is 77 degree, then it is same, north of 77 degree east. If it is 107 degree, then how it is going to be? This is 107 degree. This angle is 107 greater than 90 degree. 107 degree. What is this direction? This is south. This is east. Okay. And from where we will taking the angle? We will taking this angle. It is 180 minus 107. That is equal to 73 degree. What is this angle? South east. So south of 73 degree east. This is 77 degree east. Okay. Then again 120 degree again is going to be this 120 degree. If we take, it is same like this, south east going to be the direction. Okay, and the angle will be 58 degree. Then again is 265 degree. 265 degree will have to lie. This is going to lie in this quadrant. 265 degree, somewhat like this. What is reduced bearing? South of west. This is south. This is west. And what is this angle? We will take angle from here. So this angle 265 minus 90. 265 minus 180 degree. That is equal to 85 degree. So south of 85 degree west. Okay, it is clear. Now what you have calculated, the given declination. Declination is west. Remember that here given declination is west. I am writing declination. Okay. Given declination is what? 12 degree west in all the cases. Writing this like this. Okay. Now we have to calculate what? True fore bearing. What will be the true fore bearing as reduced bearing if the declination is 12 degree? This is not the answer. This is just the reduced fore bearing. We have to calculate true fore bearing. Okay. What is the true fore bearing? Now we know that true bearing, here it has true fore bearing, but we know that true bearing, magnetic bearing is equal to declination. This is the basic definition of declination. And if the declination is west, it is, this value is negative. This value is negative, declination west. If it is declination is west and it is positive, if declination is east, this we know that. Now from here you can calculate, if suppose you can directly write from here also you can convert it into, so for this you have to just decrease 12 degree in all the answers. You will get the true fore bearing. That is, okay, I will explain you. From here you can write that true bearing is equal to magnetic bearing minus declination, because declination is here negative since it is west. Okay, so you have already calculated the true fore bearing. You have already calculated the true fore bearing, that is in reduced fore bearing format. So you can directly minus 12 degree west in all the equation, in all the values over here, and you will get the true fore bearing. True fore bearing. I am writing as TFB. True fore bearing as north of 20 degree east. Similarly, north of 65 degree east, similarly south of 61 degree east, south of 46 degree east, and south of 73 degree west. What it did, I simply subtracted 12 degree here, minus 12 degree everywhere from in all the questions. You can also convert this into whole circle bearing. It is in this format. It is whole circle bearing. It is from a whole circle bearing, and you can use this equation to calculate the true Fore bearing, and then you can convert into reduced bearing. You can do also that also in both the ways. It is not mandatory to use the same equation which I am using. You can convert this. You can convert this into. I have converted this first into reduced Fore bearing. You can directly calculate the true Fore bearing in whole circle bearing format, and then you can convert it into reduced bearing. You can do it likewise also. So it will be correct in both the cases. So quickly moving to the next question. This was the end of this question. Let us move to the next question. It is 2b. Okay. Now next question is, the following observation were made to determine the sensitivity of two bubble tubes. Two bubble tubes we are having, A as A and B. Okay. Determine which bubble tube is more sensitive. We have to calculate which one is more sensitive. The distance of the staff from the instrument was 100 meter. Okay. We calculate this D as, say this as D, 100 meter, and the length of one division of the both bubble tubes is 2 mm. Length of one division is given as 2 mm. Okay. Length, that is L. We calculated this by 2 mm. Now, very quickly, we must know about we first must understand the theory of this. What is the sensitivity of bubble tube called, and how we understand this? Okay. So, suppose this is a spirit level. It is also called level tube or bubble tube. Spirit level, level tube or bubble tube. Or we call all the three things. And this box in this section, suppose, which contains a bubble. Okay. Which contains a bubble. This is its left hand side, the reading which has been given, and this is its right hand side. Okay. And in the center, if the line of sight is horizontal, the center of the bubble tube is at center. Where it is used, for example, if you are doing a survey, and especially in survey, when the station is changed, we use this bubble tube to level our tables in plane table survey. For example, if we are changing the station, we level our plane table with the help of spirit level. We also use practically we are also using for suppose we are building a staircase railing. So we have to check if the slope we are giving in the railing is correct. There also we use in marble flooring also. This spirit level is also used in marble flooring. So these are the practical examples where this bubble tube is basically used. Okay. So now if I want to remove, if I want to move this table, this spirit level in, suppose, in this direction, if we move this in this direction, theta, okay, and we call it as theta, this bubble tube will also move, and it will go in this direction, and we take the reading as RHS. Okay, this is the RHS reading, and if we move it in this direction, clockwise direction, then bubble tube will go in upward direction, and that reading will be LHS. Similarly, we are doing it, and we are intercepting lines. We will understand. Suppose the angle from which it moved was theta. Okay. Suppose each division, it has divisions, as each division is L, and the total number of divisions, it means total number, if there's n divisions, total number of divisions will be NL. Okay, and this is R, which is the radius of curvature of this, and this you must understand that the curve, the bubbles which moves in a curved path. The bubbles which moves in a curved path. What will be theta? Theta is equal to, we can write NL upon R. We know this from simple geometry. Theta is equal to NL upon R. We can write this. Now, if we are suppose there is a staff and this is a station, and we are citing this point, and we cite this point as, and we write the reading as S1, and then we again tilt. Suppose it's dumpy level, we are having a dumpy level or tilting level. Okay, this is S2. Suppose this reading is S2. Okay, and the angle which we moved was theta. This theta and this theta is same. Okay, what will be theta? Theta will be S2 minus S. Suppose this is equal to S, this is equal to T. We can write what theta is equal to S2 minus S1 upon D. So actually it is tan theta, but since tan theta is small, we are using it as theta. So this is equal to S upon D, which is equal to, from here it is equal to NL upon R. Okay, now we can write theta is equal to S upon D is equal to NL upon R. This is the equation. Now this is theta. This is not sensitivity, mind you. This is not the sensitivity. And what is sensitivity? Sensitivity denoted by alpha, and alpha is equal to theta upon n. Suppose for first condition, theta alpha 1 we are calculating. Theta is theta upon n1, and alpha 2 is equal to theta upon n2, and n1 is greater than n2. If n1 is greater than n2, that means what? For the same angle of rotation theta, this value n1, this the alpha 1 will alpha n1, if n1 is greater than n2, alpha 1 will be less than alpha 2, right? So if now you see the which one of the if this for the same value of theta, if n1 is greater than n2, then what will happen? The value of alpha 1 will be less than alpha 2. Okay, you can see, so see from here that that is the conclusion. So for increasing the sensitivity, what we want for the same angle of theta, the number of deviations which the bubble takes is more. For the same angle, if we want to increase the sensitivity, we must have studied sensitivity in ammeter and voltmeter when you studied when you had studied this in basic electrical engineering. So what is the sensitivity? Basically, for small value, if you are taking as an ammeter, for small value of current, it is giving more deviation. So it is same like here also. For the same value of theta, if n1 is greater than n2, then the sensitivity, that is, if it is giving more deviation, then the sensitivity of that will be more. Okay, you will be understanding when we do the question. When we do the question, you will be understanding. If we are moving more divisions, that is, if for same value of theta, the bubble tube is moving to more division, that is, it is going to be more sensitive. Okay, you will be very easily understanding that. If you are not understanding over here, you will be very easily understanding that when we do the numerical problem. So now one thing more. Now we know that in pi radian, since the value over here which we will calculate will be in degree, will be in we want to convert that into second, because the unit of sensitivity is taken in seconds. So pi radian is 180 degree. Therefore 1 radian is equal to 180 upon pi, and we convert this degree into second, that is minute into second, that is equal to upon pi. This comes out to be approximately equal to 206.265 second. 206.265 second. So alpha can be written as S upon, from here alpha this is equal to 20625 second. Theta is equal to, So sorry, alpha is equal to theta upon n, that is equal to s upon, we can write from here we are writing if s upon nd is equal to nl upon r into n. L and cancels each other, that is alpha is equal to s by nd, and we are converting, if we are converting this into second, this will be equal to 206,265. This will be one of the formula, and also alpha is equal to L upon R. If you are asked to calculate the radius of curvature, you can calculate from here also. Okay. Now very quickly moving to the question, I am deleting this. Okay, and very quickly we will move to the question by following this theory. Okay. Okay. Now, in the question it is given, the following observation made to determine the sensitivity of two bubble tubes, bubble tube A and bubble tube B. Suppose we are taking for bubble tube A. Okay. The LHS reading was 13 and 8, and the RHS reading was 5 and 12, and the staff reading, that is S2 or S1, whatever it may be, that was equal to 1.681 and 1.671. So what does that mean? Bubble reading first bubble reading was 13, suppose this is center, and 13, and in the second it was 8, and the RHS reading was 5 and 12. So 13 corresponds to 5, this one, and 8 corresponds to 12, this one. What will the value of n then? We will taking the average, that is 13 minus 5, that is bubble tube moves from till LHS to RHS. If it moves, that is equal to 13 minus 5, that is equal to 8. And how much this moved? In this case it will be 12 minus 8, that is 4. And we will taking the average. Total movement was, we will taking these two's average, that is 8 plus 4 upon 2 is equal to 6 divisions. It moved 6 division, that is value of n is equal to 6. Value of n is equal to 6. And what is the staff intercept? Staff intercept is equal to S2 minus S1. S2 minus S1 is equal to S is equal to 1.767 minus 1.681 is equal to 0.086 meter. This is equal to 0.086 meter. Now very easily we can calculate the sensitivity. What was sensitivity? We had already calculated. Alpha is equal to S upon ND into 206,265 second. Okay, this is equal to 0.086 upon, what is n? 6 over here, and D is given, question in D it is given 100 meter. Staff reading was taken from 100, that is this reading which we took from at the staff, this was 100 meter. Right, this is S1, and this when we took, this is theta, this is S2. Okay, staff reading it was 100 meter, 6 into 100 into 206,265 second, that is alpha is equal to, what comes out to be 29.56 second. I have already calculated this, 29.56 second. Okay. Now in the second case, similarly, what happened? Take, this is LHS, this is your LHS, this is your RHS reading. Okay, first we are calculating now for B. Okay, so let us see in the question. It was 15 LHS and 6. LHS was 15 and 6. So let me write this. It says 6. This is 15. This is the supposed center. Okay. Now RHS, what was the RHS reading? That was equal to 3 and 14. Okay. Like this. This is 3 and this is 14. In which 15 corresponds to 3. 15 corresponds to 3. That is this, and 6 corresponds to 14. Okay. very easily we can calculate. That is, what will the number of division in which when it was moved left, that was 15 minus 3, that is equal to 12, and over here 14 minus 6 equal to 8, that is 12 plus, this will be average, we'll taking this average, 12 plus 8 upon 2, that is equal to 10. That is, this is, and value of n here is 10, that is 10 division. Similarly, we can calculate the value of alpha. So this was alpha 1 and this is alpha 2. Okay, alpha 2 is equal to S upon ND into 206.265 second. S is, what will be the S? Value of S over here, 1.635 minus 1.788, right? That is equal to 1.788 minus 1.635 divided by the number of divisions is 10 and D is 100 as it was in that case, and D is equal to 206.265 second. This comes out to be 31.56 second, and now you see that thus here sensitivity is more. And you can also, you must, if you did not calculate it, this value alpha 1, alpha 2, we have calculated alpha 1 as like this. Here you can also see that the number of divisions in which it moved in the first case was 6. In the first case, number of division which it moved was equal to 6 division, and for the same value of theta, and this, for this it has moved 10 division. Here you can also and therefore the value of alpha 2, that is alpha 2 is greater than alpha 1. Okay, alpha 2 is greater than alpha 1. So here this one is more sensitive, and in this case alpha 2 is more sensitive than alpha 1, that is the bubble tubes, your bubble tube B is more sensitive than bubble tube A. Okay, here theta was not same. You mind you that here theta was not same. Why? Because this was bubble A and this was bubble B. If you want to calculate theta, what is theta? Theta is NL upon R. N in the first case was 6, and L what was L? L the question it was given 2, and L upon R basically was constant for both the tubes, and it was given as for both the bubble it was given as 2 mm. That is, theta was constant in both the case. In the theta was not constant in this case. Theta was not the same. Theta is 6 upon 2 upon R, and this will be theta 1, and theta 2. What will be theta 2? That is 10 divisions into 2 upon R. This was same. So theta here, you can also see that theta 2 is greater than theta 1, although it is not related to that. Okay, alpha is equal to theta upon n, right? So alpha is related to theta if n remains constant. Alpha you can relate to theta if n remains constant, but here n is changing. That is n1 is 6 and n2 is. This is just for understanding. You have already solved the question. This is just for understanding and going more deep into the questions. Okay, so theta was not same in this case. In earlier questions in which there is same bubble tube, and we have only one bubble tube. Then if you are moving from at that situation, theta is same, but over here theta changes. You can see from here that theta is changing. So this was just for understanding. You can just the basic conclusion is that the bubble tube B is more sensitive than bubble tube A, as the alpha value of bubble tube B is greater than bubble tube A. Okay, thank you very much for this one. This was last. We will be continuing this test paper in the next lecture. Thanks for today. Thanks for watching, students. Thank you very much.